Hi there, this is a video that I'm doing specially for a question that I found on the CIE teacher site that was asking specifically about this question. It's a good one, so I thought I'd do a little video on the answer to this one for all of you doing Pure Maths 3. This is a vectors question. It's question 10 on page 174 of the Pure Mathematics 2 and 3 book by Neill and Quadling. We've got a railway tunnel underground given by this vector here. The units here are in meters, and the center line of another tunnel stops at this vector here. So if you think of it as a point, that's 200, 100, negative 25, and it's heading off in this direction here, 5, 7 and u. Now this is the tricky bit. We have to choose the value of u so that when the tunnels cross over each other, there's 15 meters difference in depth between the center lines of the tunnels. So we need to find the value of u that's going to make that happen. And secondly, if the second tunnel, this one here, 5, 7u, must not be inclined at more than 5 degrees, what additional restrictions does this impose? And so what's the value of u that satisfies both these requirements? Let's get a visual idea of what's going on here. I think this is really helpful. So I've got the graphs here, just looking down from the top. So if you imagine we've got the x and y plane going on here, and I'm just ignoring the z values for now. What I'm trying to do here is find the point where the two tunnels cross over. So I think the easiest way to do it, and if someone else wants to let me know a better way of doing it, there probably is, but this is the way I do it, is come up with the equations of these two lines, just looking down from above, and find out that point of intersection. So if we look at the original tunnel, it was t 10, 8, negative 1. So I'm going to ignore the negative 1, I'm just going to look at the 10, 8. So this tunnel goes across 10 and up 8. So, or across 100 and up 80 if you like. Across 200, up 160. So that gives me the equation of this line. It's starting at 0, 0. The gradient is rise over run, so 80 over 100, or 8 over 10 if you like, or 4/5. So the equation of the blue line is y equals 4/5 x. The red line here starts at 200, 100. It all starts at negative 25 on the z-axis, but I'm just ignoring that now. And it's heading off in a direction 5, 7. So across 5 on the x-axis, up 7. So the gradient of this line is 7 over 5. So algebraically, here we've got y equals 7 over 5x plus c, so we've got the gradient. We also know that the point 200, 100 is on that line, so I substitute in 200 and 100, and that gives me c equals negative 180. So here's the equation of that other line. I then solve simultaneously, putting them equal to each other. Subtract 4/5 x, add 180, times by 5 divided by 3, etc. We get x equals 300. And when I substitute x equals 300 back into either one of these, I get y equals 240. So now I've identified the point on the x and y axis where the two tunnels cross over each other. Okay, if we look now at the first equation, when x equals 300, let's go back up. Here's the first equation right here, and I'm saying, well, when x is equal to 300, what's the value of t? So you can see the x coordinate is always going to be 10t. So if 10t is 300, that means t is equal to 30 at that exact point. You can also see 30 times 8 is 240. That also gives us the right y value. 30 times negative 1 is negative 30. So the first tunnel is negative 30 meters, or 30 meters below ground, where the two tunnels cross. Okay, so to get the clearance that we want, the second tunnel has to be higher than 15 meters below the ground, or lower than 45 meters below the ground, to get that 15 meters clearance. Remembering the first tunnel is 30 meters below the ground where they cross over. If we look at the equation of tunnel 2, which is given by this vector equation here, you know it goes through this point and it's going on at this vector, we can say, well, what's the value of s in this equation where the x coordinate is 300? So 200 plus 5s is equal to 300. Solving that equation gives me the value of s that I need. So if we do that down here, the value of S is 20. Okay. So the vertical component for tunnel 2, if we go back up to the equation, is then negative 25 plus 20u. Okay, we've found S is 20. Negative 5 plus 25 plus 20u. We want that vertical component for the second tunnel to be less than negative 45 or greater than negative 15. So then we just solve those two inequalities. Negative 25 plus 20u is less than negative 45. U is less than negative 1. Do the same thing and we get u as a half. So that gives us two restrictions on the value of u. U's got to be less than negative 1 or greater than a half. Here's a real help for looking at the problem. We've got the 3D model here. The red line's our original tunnel and the purple line is the one that's got u in it. You can see that point there is 200, 100, negative 25 where the tunnel, the old tunnel stops, so it goes from there. So you can kind of ignore the rest of this purple line here because we don't know what the tunnel was before that. So it goes from there off in that direction. Okay, if we spin this round a little bit, you can see what we're interested in is the point out here where they're intersecting. So it's at 300 on the x-axis and 240 on the y-axis. So let's just zoom out a little bit here. Okay, so there we can see the point where they're crossing over. If you look from the top, that would be where the two tunnels are crossing over. Yep. Okay. So at the moment the value of u is positive 1, so you can see that the second tunnel is rising up. It's going upwards from that point. And what we're looking at here, if I just get it around, is the distance there between the tunnels where they cross over. So if I change the value of k now, see the distance is quite a lot, but now it's getting less. In fact, when we got k equals 0.5, our solution tells us that that is the distance that we want, 15 meters. If I make that less and less, 0.4, you can see the tunnels are getting pretty close to each other until they actually intersect each other. Now if I change k, so it's now negative 1, you can see now that there's also a bit of distance between the two tunnels at that exact point where they cross over each other. So all the k values, if I keep going less than negative 1, is going to give us at least 15 meters of clearance. Second part of this problem asks, now that we've got our tunnel going down or going up, depending on the value of u, it can only be inclined at 5 degrees maximum to the horizontal. And so what extra restrictions does that give us on the value of u? Well, here we've got u equals negative 1. So I've got the clearance that we definitely need. Remember, u has to be less than negative 1 to get that 15 meters clearance. So if I increase the value of u, we've definitely got that clearance of at least 15 meters, but you can see the tunnel's getting really steep, actually much steeper than 5 degrees, which is pretty shallow. And in fact, what you'll find is even at negative 1, this tunnel here is too steep. So let's look at the other possibility. That is, if the tunnel's going up from that purple point there, this point here, which is 200, 100, negative 25. So if we go up from there, so now we're going upwards. So we started off that it had to be greater than a half. So you can see we've got some clearance here, at least 15 meters. And it's still pretty shallow there. So if I increase the value of u, what I need to do is think, well, how far can I go and still that tunnel isn't more than 5 degrees vertical? So if we go right up here, so let's go to u equals 2, you can see from the diagram that that's way more than 5 degrees. We've definitely got our clearance of 15 meters, but it's way more than 5 degrees. So if we look at our diagram looking down from the top here, you can see here's our tunnel, our second tunnel here in red. Now this tunnel has the vector 5, 7, u. So across 5, up 7, and down u. So if we look at just one little section of this tunnel, gone across 5 and up 7 and down u. So the top part of this tunnel here, using Pythagoras' theorem, is going to be root 5 squared plus 7 squared. Okay, now that leads to this diagram. So there's the top part of the tunnel, root 5 squared plus 7 squared, and we're going down u. Now we know this angle here has got to be no more than 5 degrees. So therefore, if this angle here has got to be 5 degrees, we can now form an equation with u in it. Because this is a right angled triangle, tan of 5 degrees is u over root 5 squared plus 7 squared. Solving this gives me u equals 0.753. Now that's the maximum value u can be. You can see if u is bigger than that, then this angle here would be more than 5 degrees. So that's the biggest u can be. We also had from part A that u had to be greater than a half to get this 15 meters clearance. So that leaves us with this final inequality here for the possible values of u.